So in your C2 book, you won't see the word tools, I made that up. You will probably see a chapter on radians or a chapter on sectors and triangles, but I've combined it all together into one topic, tools. So that's what we're going to go through. So tools represents these 5 equations that are really important. Triangle area, sector area, arc length, cosine rule, and sine rule. And I know what you're thinking, cosine rule doesn't start with an L, so it doesn't spell out tools. In fact, S and A aren't even, it looks nothing like the word tools, does it? It sort of does. T, not O, S. But what's important is that sector area and arc length are both the formulas that you need when you're dealing with the sector of a circle. So these two are about circles. So I know it's a bit dodgy using the word tools, but it works as a reminder. And I know that the C doesn't look like an L, but it sort of does. Look. Ta-da.
It's about lines.
It's about, okay, I've bluffed that one. It's not really an L. It looks a bit like a C.
It's stacks.
Yeah. But the good thing about having it in this order is that this is a good order to think through which one you might need. So, you're going to go through, look at the problem. Do I need the triangle area? Is there anything to do with triangle areas going on here? If yes, write down the formula, sub in what you know, solve to get missing info. If not, is it about sector area? Is it about arc length? Sometimes it's a good idea when you get to 4 and 5 to think about sine rule first and almost use cosine rule as a last resort.
Yeah.
So we have, one of my students said that it's L for last resort, and that's why it's an L. Still a bluff, but it's a way of remembering it, that if all else fails and you're sure it's nothing to do with triangle areas, sector areas, arc length, or anything to do with the sine rule, last resort, cosine rule. Okay, ready to learn these formulae?
Yep.
Okay, so we're going to go through them in detail, but first let's just get them all down. So triangle area, half, AB, sine, C. Excellent. Sector area, half, so they both start with a half. And then instead of A times B, R times R squared, theta. Arc length, easiest formula in the world, R theta. Cosine rule, A squared equals B squared plus C squared minus 2BC cos A, capital A, yeah. Sine rule, A over sine A equals B over sine B. That's it. Now obviously we need to know what all these letters represent, but these are the formulae that you do have to learn. You have to learn them. Okay. So let's go through again what we've got. We've got an area formula, area of a triangle, T. We've got 2 formulae that are to do with circles and sector areas. Area, so these are both to do with area, these first 2. Area of a triangle, area of a sector. Then we've got arc length is the other one to do with the circle. Only those 2 to do with circles, so that's what the U is about. Then we've got the sine rule, and last resort, cosine rule, if we don't need anything else to use. Now we're going to go through each one in turn and talk about how you would know that you need it and what all the different letters are. Okay? Triangle area. Okay. Now, if you do this with your hand, then this is the angle, C, usually we say. And these lengths are A and B. So it doesn't matter which one is your angle. Here, that could be the angle. If we use that angle, let's say that's, I don't know, I'll make it up, 20 degrees, then the area would be a half A, B, sine, C. Okay? Or, if you prefer, turn your hand around. And obviously, I need to expand the fingers here, which I can't, but using this one, if this is an angle of 100, then this one would be a half A, B, sine, C. Or, equally, we could come around here, and we could use this one. That's fine. And if this angle is 30, then we would have a half. Well, yeah, good point. They don't add up to 180, but never mind. A half A, B, sine, C. So this is a good way of remembering what your A and your B are, is to use this victory sign. with your fingers. Make sure your calculator's in the right mode, radians or degrees. We'll come on to degrees in a second. Now, in fact, radians and degrees. Okay, on a ruler, you've got centimetres and inches. So you know that you can measure something in centimetres, so you might have 5 centimetres, or measure it in inches, so you might have 2.1 inches. I don't know what the conversion is. So similarly with angles, you can have 180 degrees or pi radians. So pi, which is a number, 3.14 blah blah blah, is 180 degrees. So this is pi radians. This is pi by 2 radians. If we took a pi radians and split it up into 3, this is 60, 60, 60, yeah? So 60 degrees is pi by 3 radians. What would 45 degrees be?
45. Well, if that's pi and half of it would be half pi, then a quarter would be pi by 4.
Yeah. So this is 45 degrees, which is pi by 4 radians. What about the whole circle, all the way around?
Well, if half of it is pi, then the whole way around must be 2 pi.
2 pi, exactly. So 360 degrees is 2 pi radians. And when we do the OO formulae that we're going to do next, we must be in radians. A radian, in terms of what it actually is, and you're thinking, why are you even doing this? If you have the radius of a circle, and you go round the circumference 1 radius, then you get 1 radian. So we go round another radius, round the circumference, we get 1 more radian. We go round another one, we get 1 more radian. And you can see that 3 radians is almost 180 degrees. There's this little bit of spare here. So 3 radians isn't quite 180 degrees. So what they said was, well, how many radians is 180 degrees? Is it 3.5? Is it 3.2? What is it? And it turned out that it was this funny number, 3.1415 something something, I can't remember. And that many radians is 180 degrees. But rather than say that stupid long number all the time, they just say pi. So when you say pi, you mean 3.141592 blah 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 blah. That's what pi is. So pi is a number, 3.1415, and pi radians is 180 degrees, and 2 pi radians is 6.28 something 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 radians. That's 360 degrees. And it's radians we need for these formulae. Okay? So sector area. Nice easy formula. A half r is the radius, theta is the angle. Half r squared theta. And you can use it on a really big angle as well. So for example, say you wanted to work out this area, and you knew that this was 60, and this is 10, the radius, then you could say, but this must be 300.
Yeah.
So the area would be a half r squared theta.
Doesn't it have to be in radians?
Well done, I was just checking you. That's the mistake that people make.
Because we already know, like, an area for a sector outside of this that
Yes.
we've done like GCSE.
Yeah,
And it's normally just a fraction of the whole circle.
yeah,
So
exactly.
you do 360, or 300 over
Out of 360, exactly.
area of the circle. But this is so much shorter only if you're in radians.
Yes, exactly, but you must be in radians. So, we are looking at, like you said, a ratio. We've got 300 out of a potential 360. So that is, what does that simplify to? 10 over 5 over?
10 over 5 over 6.
Is it 5?
So, times?
Yep, okay. So we've got that much of the circle, and we know that the full angle is 2 pi.
Yeah.
So what we've got there is 10 pi by 6, or rather 5 pi by 3.
Yeah.
So the area that shade is a half r squared theta. Theta must be in radians. Okay, and then you can work it out. Now, if you remember what I said about the area where a radian comes from. So 1 radian is what you make when you've got 1 radius around the edge. So that gives us a very, very obvious formula. If I've got theta here, then the number of radiuses I've got here equals the number of thetas I've got. 1 radian, 1 radius, 2 radians, 2 radiuses, theta radians, theta radiuses. So that's the arc length, r theta. It's literally just multiply them together. Okay, actually, do you know what? We'll come back to this as a last resort. So we'll do the sine rule first. So sine rule, what you're looking for with the sine rule is the ability to do this and know both those things. So if this is 100, then you can put your thumb on 100 and your finger on 12 and you know both of them. Okay? Then you can fill in, doesn't matter which way up it is, sine 100 over 12 equals, or 12 over sine 100 equals. Now, you must have that opposite pair. If you don't have an opposite pair, so it's a really good way of knowing whether or not you need the sine rule. Have I got an opposite pair? If not, no. Can't use it, exactly. So you have this opposite pair that you know, and then you're interested in a different opposite pair. So for example, you might, I don't think I can make his fingers do it, but you might be interested in, no, I can't make him do it. He will have to just stay there on what we know. So that's what we know, those two. And then maybe we want to know what that is.
Yeah.
So we know one opposite pair, and we're interested in the other opposite pair, and that's the one that goes on the other side of the equation. Sine, don't know, over 4. Or 4 over sine, don't know.
Just as long as you keep them consistent.
Yes, yeah. Lengths on the top or angles on the top, doesn't matter which way. So if you know an opposite pair and you're interested in an opposite pair, then fine, sine rule, but you must know that opposite pair. If not, last resort, cosine rule, which was this formula. And again, you've got your fingers in this position. Doesn't matter which one, the thumb is on the angle, okay?
Yeah.
So the thumb is on the angle and the finger is pointing at A. So it doesn't matter which opposite pair you use. If this is your angle, A, then this is your A.
Yeah.
Or, if you, don't think he can do it, maybe. He can't really point that far. No, he can't. If he kind of can, yeah. If that is your angle, A, that's going in here,
Yeah.
then this over here is your A that goes over there. So it's the same shape as you need. You're looking for opposite pairs, basically. And then the B and the C, it doesn't matter which way around they go at all. Okay, so takes a while to get used to using these, but should we write them down one last time?
Mm-hmm.
So T, triangle area. Do you remember that one?
That is a half AB
Yep.
sine C.
Yep, and how do we remember what A and B is compared to C?
It is even that.
Yes, that's it. So you put your fingers in a V sign, and the angle is in between your fingers, and the A and the B are those sides that make the angle. Yep. Then we've got your OO ones. What's really important to remember about both your OOs? Exactly. Both the OO ones, and that's what that star on the bottom is for, the OO ones must be in radians. So the first O is similar to the T, area. Starts in the same way.
That's the area, isn't it?
Yeah.
So it's half
Yeah. And instead of A times B,
R.
times R. Yep. And then instead of sine theta, just theta. So we've got the half the same. Instead of AB, it's R and R instead of A and B on the triangle. So that's just your R squared there. And then instead of sine of the angle, literally just the angle. And then easiest formula in the world, arc length. There we go. Yeah, I suppose we should, I was thinking maybe we should make whole equations, but anyway. Right, L should we come back to as a last resort? And S. So when do we use S?
That's a sine rule,
Yeah,
isn't it?
and we
So
use it when,
we use it when we have one pair of opposites.
Yes.
So you've got
like here.
the angle and the length. Yeah.
So if you've got an opposite pair and you're interested in an opposite pair. Either way up is fine. And then if none of those are going to solve your problem, they're not interesting to you at all, then last resort cosine rule.
A squared b squared plus c squared minus 2ab.
BC, BC.
BC, sorry. Wow, that's messy. 2bc cos a. I was thinking about the a already.
Yeah, exactly. And then the same thing with the opposite pairs. If this is your capital A angle, then the one opposite is your little a that goes on the left of the equation, and the other two you'll B and you'll C. Oh, I tell you what, I was going to just, on each of these pages, so you need to learn these formulae, you need to write them down and write them down and write them down. But you may have noticed on each of these pages that it said the same thing at the top. Write down the formula, sub in what you know, solve to get missing info. So once you've memorised these formulas, you're going to look at a problem and go through, do I need T, do I need O, do I need O, do I need S, do I need the last resort? Then you're going to write it down. Then you're going to sub in what you know and solve to get the missing info. So it says that on every page. Write down the formula, choose a formula, write it down, sub in what you know, solve. Write down the formula, sub in what you know, solve. So every single problem that you come across, this is what you're going to do. So if you ever say, I'm completely stuck, I will say, well, do you need to use T or O or S or L? Then I'll tell you to write it down. Then I'll tell you to sub in what you know. Then I'll tell you to solve for what you don't know. So if you get stuck, you're just not following those steps, basically. So that's your main set of notes as well as the formulae, that what you do is choose a formula, write down the formula, sub in what you know, solve to get the bit that's missing.